Our project is two-tier phishing URL detection using machine learning. We are team null pointer, and I'm Surya with my teammate Krishna. So we built a two-layer system. The first layer is fast and check the URLs itself, and the second layer is deeper and checks the things like how old the domain is and whether the certificate is new or not, and what actually page looks like. Together, the system we got around 96% of accuracy. And coming to agenda, here is what we are going to cover today. The problem, our data, how we cleaned it, what patterns we found, and how we build the model. And including this, we have the results and a live demo. And finally, what does tier 2 model actually do? This is all we are going to cover. And after that, the challenges and conclusion. And starting with the introduction, what exactly is phishing? Phishing is an Phishing is when an attacker sends a fake URL to steal our passwords or credit card details. It's a huge problem. Over 36% of all data breaches starts with phishing. And coming to what's new in 2026 is anyone can buy a ready-made phishing kit online and launch attacks that specifically fool traditional URL scanners. That's why we built our project using machine learning, and it can learn new patterns that rule-based systems doesn't. And coming to the problem statement, the main problem is that five types of attacks completely bypass URL scanners. URL shortener, hide where the actual goes. And attackers put fake pages on real Microsoft and Google domains so they look clean. Some attacks steal your login cookies even after you have done two-factor authentication. Hiding iframes load the fake login form only after you click. Some scanners see nothing. And professional phishing kits detect when a security tool is scanning and show it a fake clean page. So our goal was to build something that handles all five issues. So for that, we have taken two datasets. One is Verbensic dataset with around 558K URLs is what we trained and tested in our actual model. And the second one is the synthetic dataset we prepared using AI, which we used in the tier 2 model. And coming to data cleaning and pre-processing. Before training, we cleaned the data and we removed 9 features that was same value of almost every URL. Those are useless. We confirmed there were zero missing values as no fill-in was needed. And we removed duplicate URLs before splitting. Otherwise, the same URL could appear in both training and testing, which could give us a fake results. And we encoded text columns like certificate type into numbers. URLs with no path or query were given negative so that they don't hold a place. And next, we split our data into 80-20, 80 for training and 20 for testing, keeping the same ratio for phishing to legitimate in both halves. Uh, we did not normalize the numbers because our models are tree-based and normalizing doesn't affect them. And coming to exploratory data analysis, before building features, we looked at the patterns in the data. Phishing URLs are almost 3 times longer than the real ones on an average. And coming to phishing domains, we have more digits in them compared to the legit ones. And phishing URLs go much deeper in the path, like account slash verify slash secure slash login, like that. And an important finding we found was 49% of phishing sites are uses HTTPS. Uh, and one more major thing is 83% of phishing URLs contain a brand name like PayPal, Microsoft, or Google, but put in the wrong place, like in the subdomain or a random domain. And our model found that directory length and domain activation time were the two important features, just not just URL length like most people assume. Coming to feature engineering, we extracted 90 plus features from URL string alone, no internet connection needed, and no DNS lookup, nothing, just the text of the URL. We group them into 6 types. The first one is lexical features, are things like how long it is and how random the characters look. The second one is brand features. The brand features check if a known company name appears in the wrong place or not. And the third one is subdomain features. Check how deep and suspicious the subdomain structure is. Coming to the fourth one, the path features look for open redirects and sensitive keywords. Fifth one is the obfuscation features detect things like a base 64 encoded or double percentage encoded hidden in the URLs. And the last one is composite features, combine multiple single signals together, like catching a typo of PayPal plus an action word like verification. And coming to the architecture, every URL goes through tier 1. If the phishing probability is 0.65 and above, we block it immediately. If it's below 0.35, we allow it and we conclude that as a legitimate URL. If it's in between this, we send it to the tier 2 model where the actual work goes. URL shorteners like bit.ly always go to tier 1 no matter what it is, because tier 1 has no idea whether they lead to a legit or a phishing one. So tier 2 does real network checks, DNS certificate age, redirect chains, page content, and all things are done in tier 2. It gives 3 answers: block, allow, and warn for human review. Tier 2 always overrides tier 1, except in one case. If tier 2 is unsure, but tier 1 is very confident, it's phishing, we block it. So in that way, our architecture goes. Coming to model training, here how we build the model step by step. So load the data and remove bad features, split it 80-20, run fivefold cross validation to find the best settings for each model, train XGBoost and Light GBM with those best settings, combine both models by averaging their predictions, calibrate the output probabilities so they were accurate, and tune the decision threshold using the precision and recall curve, then test the 20% uphold set we never touched during training. And that's how our evolution and model training went through. And coming to the confusion metrics, our test set of 11,000 URLs, 5,800 were phishing correctly caught, and 5,300 were legit correctly allowed, and 280 legitimate incorrectly flagged, and 246 flags that slipped through. Overall accuracy of 96%, around 96%, and the AUC around 5 folds is 0.9922 with a standard deviation of 0.0015, meaning the model performs consistently regardless of what data we tested on it. And coming to ROC and feature importance, the ROC curve shows both our models are well above the random baseline. Adding DNS features on the top of URL features improve AUC from 0.9661 to 0.9915. The feature importance chart shows directories length and domain activation time are the two major important things, which means path structure and domain age matters more than just how long the URL is. So coming to model performance, we tested 5 different model setups to understand the trade-off between speed and accuracy. URL only with 27 features gives 91% of accuracy in under 1 millisecond. Perfect for browser extensions. Adding DNS features gets up to 95%. Using all 111 features, we got up to 96%. Both outing and stacking also got 96%. They are all hit the same ceiling. That tells us the limit is the data set, not the model. Adding more complexity won't help. It's just overfitting, not improving. That's what we found. And finally, the system demo. This is the live predictions we got. So this is the real output from our notebook. The fake PayPal URL with correctly flagged as a phishing with 99.98 confidence. The real PayPal.com was currently allowed with zero phishing probability. The Outlook open redirects and the bit.ly link were both triggered as uncertain and were sent to tier 2. So my friend now going to discuss about the tier 2 model, how he trained it and how it works.
Thank you, Surya. Now I'll be explaining about the tier 2 model. The tier 2 exists because some things are completely invisible to URL analysis. Like you can't tell from the URL analysis whether the shortener redirects, where does it go, where does it land. You can see a hidden iframe in the login. You can see if the redirection comes from a JavaScript. You can check if the certificate is like issued like 5 minutes before. It has no idea about the domain that we are using. So the tier two features we have collected like 80 features across 8 groups. Like DNS tells us how old the domain is, where it has proper email security records like MX records, and then where the IP address is coming from any bad name server. uh, if it's a free provider like phishing, all the phishing toolkits like to use the free providers, and the redirect sign tells us how many hops the URL is taking before it lands on the final page, and then is it in the same domain that we have clicked the link, or is it landed on the different domain. The page content tells us if there is any login form, or what type of JavaScript it has in it. And then the cloaking tells us if the site behaves differently for like different visitors. And yeah, the tier 2 model, we have 80 raw features, and then the problem we need to normalize these data because uh some of them have like very big data, and then some has like very small numbers. So when we have to train our model, we have to train it so that it doesn't get confused. So I wanted to normalize the data. So all the domain age, we shouldn't be having big numbers. So I try to make it small, and then uh, s- uh, we log transform the very skewed ones, and then group continuous values into risk bands, reduce like 11 correlated features into like 3 using PCA. We needed PCA so that we can bundle all these same like features into single ones. Then with these, I have trained the XBG boost and light GPM models on these because it's easier to train the probability conditions with these models rather than regular expressions, or like neural networking we might need like millions of data, but we are working with small amount of data. So I've used XGB boost and light GPMs. And for the tier 2 evaluation on 300 URLs, the tier 1 handled like 289 perfectly on its own, and it has sent the 11 to the tier 2, and tier 2 classified all the 11 with full confidence. We have 6 phishing, 5 legitimate, and 0 sent from so we don't have anything for the analyst to review. So the final result for this model is like 98% accuracy, and it's giving us 100% precision. Like the six missed were all the URL shorteners chains that were used, and the tier 2 couldn't follow the redirect without the live network. So the challenges we faced during this is we have 6 problems here. All the models plateaued at 96%. We accepted this as a data ceiling, not a modeling problem. Conclusion, this project demonstrates that a two-tier machine learning pipeline was achieved with 98% accuracy on real phishing URL detection. We maintain like 0 false positives, which we have extracted 81 URL structured features alone with no network calls required. Remaining uncertain cases are escalated to tier 2, and this tier 2 performs the live DNS resolution and then TLS certificate inspection, and all the other things we have discussed before. And this is our project. Thank you.